Hello everyone, I'm Xiao Gang. Okay, in the last lesson, we completed the server interface, and now we'll work on the client interface. But first, let's go to our subsystem. If we have a server side, we definitely need a register interface, right? This interface is actually the same. We put this register in the position above. Registration should happen before login. We haven't declared this delegate yet. Now let's declare this delegate. This delegate, I'll move it over here. It's actually the same. It's very similar to this login interface. It's a bit long here. It might not look very comfortable for everyone. Let's arrange it like this. This way, it looks more comfortable for everyone. The first one is the username. Okay, it has 5 parameters. Actually, this register also has 5 parameters. So these 5 parameters are actually the same as our 1, 2. I haven't written this yet. Touch it. Okay. So actually, these 5 parameters are the same as our login parameters. Okay. This place has 5 parameters, right? You see, they all correspond. What type of request is this? It's unique new identifier result. Then what type of result should it return? Pull it up here. Okay, then this is the actual data it carries. Then let's go back to the subsystem. You can see here, it should be okay now. Let's double check it. Change this part here. Make sure it compiles successfully. Then make sure to update all corresponding parts here. Okay, let's go back to our subsystem. At this point, it should be okay. Let's create it. Its implementation. Okay, now let's compile it first. Because I pasted it over, I'm afraid I might have pasted something wrong. Okay, the compilation passed. So let's build the BP library first. As for the BP library, its build logic is actually the same as the login interface. Let's just paste it over. Let's put it here. Then we can take a look. The data here should be fine. Let's just stick this on. This world context object, and then this proxy, then the data we requested is okay. Then there's no problem. We create its implementation. As for this implementation, it's actually just copying this part over. Then we also copy this data over. After copying it over, we need to change the name of this interface because the one we're calling is currently calling this interface. Let's go back. Okay. At this point, it should definitely compile successfully. No problem. So next, we will take this process and embed it into our client framework. Okay, so actually here, let's come back here again. Let's not write this register for now. Let's first find this register. It should be called. After it is called, this process is actually the same as the login process. It just checks the data, then retrieves the configuration, then records the proxy locally, then deserializes its data, and then sends it out. When sending, you mainly need to change this enumeration, and that's it. Then we still use the same writing method. First, we prepare a response result. Then we declare our widget, declare the widget identifier. Then we check whether our data is correct. It's not just secondary data, because this data might not be correct. Then this data is passed in through this parameter. When it is passed in, it will give this result. This result will verify the username, password, phone number, email. If any part fails verification, it will return an enumeration. Give a false, then we just copy this over. So if this data is incorrect, then we need to execute this delegate. And as for the struct, we need to use the response struct. That is, we use this one. It's struct. We can remove the response as put that here. Okay, then we also need to change this login request. It is no longer a login. It actually uses a registered request, right? Okay, so this part is verified, whether this data is correct. Next, let's retrieve our server configuration to see if it can be retrieved correctly. Similarly, we need to prepare this data. Because we need to prepare a blank data in case the call fails, we just need to execute this delegate changes request. After entering it locally, we need to record this delegate again. because our delegates all look different. So we need to change the name here. So the name that was changed, it will no longer log into this DMAP, log into a tab. We change it to a registered time map. Okay, then we add the registered TE map into it. And this is the one passed over. It is the registered proxy route. So we have recorded this registered proxy. Next, we need to deserialize and process the data. Let's also bring the call over. Bring both 4 and 5 over. We'll modify them one by one. And then as we think about this data, the data we need to send, it should be the data of this request we are going to make. Its password needs to be MD5HC. Yeah? Right. We'll just hash it in place as before. Then we directly customize this data. Directly use convert to converted to this JSON. Convert it to this JSON. Okay. So here we are registering. And our data is this data. Then on our delegate, we declare a delegate. So actually we have completed the first step, that is these few steps. It's equivalent to us doing verification. Then we get the server data. Then we encrypt the data, then deserialize it, then finally send it out through this interface. We won't touch the remaining HTTPT. Then we go back to our response here. Here in the response, we use it. We handle the correct case first. We haven't written the registration yet. So we'll add the registration. It's the same. Here we first paste the break. Then here we paste the registration. If it's this registration, reply, right? First, let's check. Let's check our currently registered map. It should be greater than 0. Yes, it's greater than 0. Only then do we look for it. Otherwise, there is no such map. We should probably use an assertion to check. And then over here, then we look for this delicant. This delicant. It's very similar to our delicant. This delicant should have been registered. So we should use it. Remove this. This place should use this. Here I switch by toggling the header file. Okay. Alt+O. Here I use Alt+O, which is the VS shortcut. Then after switching here, we look for it. If we find it, then we execute it. So obviously we need to prepare a piece of data first. Then this time the data should be the valid data, and this data is it. Then let's just copy and paste it. No need to write it manually. Writing it manually would be very painful. Okay? Once the data is ready, we start doing this charging work. Then let's just copy and paste it again. So if we serialize it, here we serialize this struct to this location, and the request saving is here. Actually here. Yes, it's called login server response. No problem. Then you continue serializing. It might succeed or fail. So for the success and failure cases, we need to handle them. If it succeeds, actually we can directly execute the delegate we found. This delegate is actually registration. We can add the registration prefix to it. This way it will be clearer when you write it. Then the request type delegate. These were all passed through when we were binding earlier via the function signature. And this result is from the first level data. This is also from the first level data. What we actually need to return is the struct of this second level data if it fails. Actually, it's the same here in this place. Remember, we need to remove it at the end. And I missed writing it. This part was missed. It will take up a bit more memory. Actually, it should be fine, not a big problem. And then, so failure is actually the same. Here we are, executing the registered proxy for this. And obviously at this point, parsing the secondary service data has failed. Then we just move it back. Okay, so the client side is done. And this is all quite simple. Let's just test it directly. Let's start the server. When the server is started, let's take a look. Take a look here. Okay, there's a compilation error here, right? Let's check what the cause of this error is. Let me take a look. It's this place. It seems to suggest that we must return a value. We missed something here. We missed the server part. It should be fine. Let's switch it back. Wait a moment. It should directly return this character here. When we were writing the negative loop, We were only thinking about returning it. We forgot to return this character. Let's fill it in. Then let's start it again. Okay, good. We have now started. Let's take this. Open the level blueprint. Then we need to construct this data here. We'll still use this one. Then we put it below. Then here we use the most recently registered one. Then we need to construct the registration data. So let's keep it simple. We'll give it a name, 小gang. 小gang 001. For the password, we'll use the same one. 1 2 3 4 5 6 1 2 3 4 5 6 7 8 9 1 1. Okay, for the email, we'll use 50,623,16 Byzantine a bit. Okay, in actual development, these things require more complex judgments. These things also need more complex determinations. Just like a phone number, it must be unique, and an email requires verification. These things are all very normal. This part is not the focus of our development, because these are more back-end oriented things. Slightly more back-hearting. Then here, we write this reject. Event writes this practice well. Okay, then we can just copy this thing over. Let's take a look. It should be these three brothers. This way we don't have to bother writing this. Okay, good. We need to do this brick here. We'll just print it out. Good, then we'll print it again here. Good. Let's look at the data we return. Username, udude, we'll add a time. As for this time, it might be quite troublesome this time. At this time, we'll just get an hour, this one time. We have to piece this together ourselves. It's annoying that this character doesn't count. It's okay if we piece it together. Change the display date, and we'll piece together a month. Right, month, then date. That it should be hours. Hours. Then it should be minute. Minute, second. Okay, let's break down this time structure. Yeah. No, we don't need year, just month. Day. Oh, minute, second. Then we pass this time here. Okay. Now let's test to see if it can register successfully. We press 1. It already shows registration successful here. And the registration time is 10:47. Right, this time is fine. Now it's a duplicate name. Let's try it. Let's see if we can log in with this. Then we use the number 2 key. Let's log in first. It's xiaogang001. Right. What was the password we registered? The password is 1240-506. That's pretty good. Let's try again. Let's show everyone. You can see the login was successful. Right. Then at this point we can take a look. If we enter our name randomly, let's see if it can successfully complete this verification. For example, let's just put in Xiaoha. Obviously our name length doesn't meet the requirement. You can say, look, on this client side. Right here, the client actually blocks it for you. Right, because our server never even received it. The client side. So this is pretty good. Okay, so that concludes the chapter for everyone. Let's review this chapter again. Actually, we mainly built a server. We wrote the server code, then we write the client code. The server runs as a standalone program. It was already written as an HTTP server. As for the client, you used the UE plugin to send HTTP requests. We briefly used MDIV. Then we created 3 interfaces. These 3 interfaces are respectively check vision and this local response event and this register event. Okay, We'll stop here for this lesson. Thank you everyone.